Those of you who know me, this is Mr. Taylor by the way, know that I am very bad with balloons. Because of how small my lungs are and because I'm just not good at tying balloons. I will admit to you, I almost twice messed this one up and it took me over 10 minutes to tie all 3 of these. So shout out to Mr. Taylor's students, my students, for already knowing and dealing with how bad I am with balloons. But there's the balloons that we have, and we're going to be taking those measurements pretty soon. But first, what I wanted to do is just go back over here and look at the values. And I'm going to update this. It still says it hasn't updated since 8/15, which it still says, but it says it's negative 14 degrees Celsius out, which we can use. Again, it's Fahrenheit's really, 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 really bad. So we don't want to do that. It says the pressure is 103 kPa. And the temperature inside, which is what we care about, is approximately, let that focus for you guys. That line is 20. I know it's not focusing very well, but this line right there is 20. I'm going to try to maybe go more on the black to see if you can see it. But there's the 20. There we go. And if I roll this just a little bit, it's right at, it's a little under 19. I know it might be hard to see on camera. So that's going to be 19. Or just a little under. I actually already looked this up, and it's going to be 18.8 degrees Celsius. So there's, you know, over a 30-degree temperature difference from inside to outside. And for reference, it's 65 degrees essentially in this room, and outside it's 7. So just to show you guys that. Again, really cool. And again, we're just using the Weather Channel and some conversions. But now, let's do the part that we care about. Let's get the circumference of these spheres. And again, not going to be perfect. These are not spheres. But we can do the best we can. And again, we need to use centimeters for this. Because again, inches are bad too. Gotta be in metric. We're not using inches. So this is going to be centimeters. And again, I'm going to do the best I can to make this a circle. So for this one to do that, I'm doing the best I can. Just kind of squishing it a little bit. And I'm getting that the circumference is about, I'm sorry, I'm trying to keep it on camera. We are right at 15 centimeters. We'll write that down. That's the half one. The next one, and again, trying to get it to be as much of a sphere as I can, so I am squeezing it. This one's a little bigger, so I can actually roll the measuring tape behind my hand. This should make it a lot easier. I couldn't do it with the last one. This one, 24 centimeters, which is 9 centimeters bigger. And this one, again, I'm going to lace the measuring tape around. I'm going to squeeze this to try to get it to be as much of a sphere as I can. That was actually pretty good. And what I'm getting for this one as I adjust, because it slipped a little bit. There we go. We are right at 30. So 6 centimeters bigger on that. For reference, that means that from the 1 to the 2, it's this much bigger. Now that we have the circumference, I'm going to have you guys figure out the radius. Again, the equation's in the worksheet, in the form. And then after we have that radius, we can go from circumference, radius, plug this in, and you get the volume of these 3, and will allow you to calculate the moles. Really cool lab, really easy lab, just needed water, Alka-Seltzer, and a way to contain it. And again, there's things that went wrong, it happens, but you know what? We learned a little bit. The reason why I put the temperature outside is, in the next video, I want to talk to you about what happened with the 2 balloons that I blew up beforehand.